Gracias. Now in English. So, I'm from Brazil. I'm a CTO of a video platform called Winning. And we are a startup. We have 2 years. And I'm a software developer for 9 years. And I also worked with JavaScript, Scala, and Java. And this is my first conference out of Brazil, so I'm really nervous. Thanks. So I will show some code for you, and also you can download the presentation at this link. So this is the talk, microservices on Node from zero to hero. And as we are going from zero, I will first talk about the monolithic architecture. What are the problems? What are a monolithic architecture? And then we will talk about the microservice definition. What are the advantages and the benefits of this architecture? And also, what are the problems with this architecture? Because a lot of people talk about microservice, but no one talk about the problems. They just try to sell you the microservice. And then I will show you how we can implement this in Node, and we show to you some code. Okay? First, a monolithic systems are those where all our services are running the same process. So we have a large code base with all our services running the same process using shared resource of the same machine. And the problem is, as we are sharing resource, if we have a service with an infinite loop or a database lock or a memory leak, or as we are talking about Node, even a single non-treated exception can make our whole system crash. And this is a problem for us. So, no shared resources, pure love. Keep this in mind. And another problem with monolithic applications, they are really hard to change because we have a large code base that tends to grow exponentially. And they are hard to deploy. And as we are sharing resources, they are really hard to monitor because it's hard to find the bottlenecks. We need more tools to find the bottlenecks for our application. And trying to solve these problems, the problems with the monolithic systems, the reactive manifesto was created. You can see the full manifesto following that link, but I'll talk with you about 4 patterns that this reactive manifesto created. These patterns, they give us a direction on how we can achieve scalability and the modern requirements, because your boss wants you to handle petabytes in milliseconds with no downtime. And we know that's not easy to do. So the first thing, we need a responsive system. And responsive systems are those who provide low and consistent response times. They establish reliable upper bounds so they can deliver quality of service. At this point, we have no problem with monolithic system, as the monolithic system can be responsive. They can be fast, they can deliver the response in low time. But the second stage is that our system needs to be resilient. And being resilient means that your system stays responsive even in face of failure. And we talked earlier about the problems with shared resource, as a single error can make a whole system crash. So resilience is a big problem, a big concern for monolithic application. And resilience is also achieved by replication, containment, isolation, and delegation. Resilient means that you are able to contain the failure on the service where the failure happened, so it don't make your whole system crash. Our system also needs to be elastic. And being elastic means that your system can stay responsive even when the workload is increasing. And this implies that you need an architecture with no central bottlenecks, and you need to provide some kind of life performance for your application so you can detect your bottlenecks and fix them quick. You also need to rely on message passage. Reactive systems are those where you always communicate using message passaging through your services. And using message passaging ensure that you have no hard reference between your services. So you can divide and redistribute your code as you grow. Using message passage also means that you need to use the same constructors if you're running in a single host or in a cluster. So now that we know what are reactive systems, let's see what are microservices as stated by Martin Fowler and see if it fits the reactive manifesto. I'll read with you the definition and highlight some points. First, the microservice architecture style is an approach to developing a single application as a suite of small services, each running in its own process. So, a microservices architecture don't share resources between services, and they communicate with lightweight mechanisms, often in HTTP resource API. So they use message passaging always. These services are built around business capability and independently deployable by fully automated deployment machinery. So it's easy to deploy microservices architecture because you can automate this. And there's a bare minimum of centralized management of these services, which may be written in different programming language and using different data storage technologies. So the key concepts of microservices are, we have small services implementing a business rule of our business, and they use lightweight communication because we are going to use network, and communicate through the network is always slower than using shared memory of monolithic applications. They are independently deployable, and they have a minimum management of centralization, so you have no bottlenecks, you have no single points of failure. The benefits of microservices are, they don't have shared resource, and as I said before, it's pure love, don't share resource, never. It brings independence between your services, and they are easy to change and to test because they have a small code base when compared to monolithic system, and they are easy to deploy and easy to monitor. And they are easy to monitor because you don't have shared resource. So if you have a problem in the service, you can quickly identify this problem and solve them. And the problems are communication through the network. Communication through the network is always slower than communication using shared memory, and you also have to handle network failures. Another problem is when you're creating a microservice architecture, you probably have a big business to implement. So you will have hundreds of services. So one of the problems is how a service can find another service on the network. So service discovery is a big problem. And it also might be hard to decide how and when to decouple to redistribute your code, your service. Now that we know what are microservices, let's talk of how we can implement microservices on Node. So the first thing we need is a router. A router is an object capable of receiving and delivering a sync message to our services. This router also must be capable of finding the service on the network. We also need immutability, so a service can mess with the internal state of an object of another service. And if we are dealing with hundreds of services, we probably need a namespace to avoid name collision of this service so you can identify each service uniquely. And it's good to have plugins or add-ons to add performance measurement or other things that you might need to your system. And in 2014, I was working in a company, in a startup in Brazil, and we were about to create a new product. And we were creating our MVP, and we wanted it to grow a lot. So I faced the following problem. How can I create a system and distribute it as it grows? And to solve this problem, I created Studio.js. Studio.js was highly inspired by the actors model, which is also used by Akka, which is a framework for Scala and Erlang. So it inherits a lot of this model. And we used the studios on the company on 2014, but we found it hard for new developers to use the framework because it was really highly inspired on the actors model, and most people don't know the actors model. So I decided to rebuild the user-facing API in 2015 with total focus on developer happiness. Studio is MIT licensed. It has a powerful core. Studio just try to make sure that you are creating a distributable system, but it don't distribute, doesn't deal with network communication for you. To do this, we have a plugin of Studio, which the Studio cluster, which does the clustering for Studio applications. We also have other plugins for Studio, like gathering usage metrics to send to StatsD or any other dashboard that you might be using. Studio also can do timeouts, retries, and give you better errors. And you can create your own plugins with just a few lines of code. So let's talk about Studio Cluster, which is the main plugin of Studio, the most important plugin for Studio. Studio Cluster tries to solve two problems. The first one is service discovery, and how Studio Cluster can find your other service. Studio Cluster makes really easy for you to distribute and communicate your code, because you can use Studio Cluster with no configuration. One of the ways that Studio can find other service is using network broadcast. So I will show you this on my computer, but if you are running two Studio processes in the same network, they can find each other and communicate and use network broadcast. But if you are running on an Amazon VPC or any other network that doesn't support network broadcast, Studio can also use a Redis server to find the other service. And the second problem is remote procedure call. Okay, now I know where all our services are, but I don't know how to communicate this service. So after a Studio process find another Studio process, they start WebSocket communication, and they do service call using this connection. This is a peer-to-peer based connection, so it can also deal with network failures, with service crash, and I will show you all these problems happening on my machine. As I said before, Studio now focuses completely on developer happiness, so for this reason, I tried to make it compatible with ES6, so we have generators. For those using async await, you can do in a really similar fashion using generators on Studio without using Babel. We have proxies to find another service in the network, and we can use classes to build namespaces and create several services easily. So I will show you some code on how to use it. First here, I just created a simple application with two dependencies, Studio and Studio Cluster. And I will show you the two services communicating. First, we have these two simple services. The first one is full, which calls the bar service. And I will call this service every second. So I'm only importing Studio here. This line of code just tells Studio, Studio gives me all the service that you have, and Studio don't enforce you any order because as we are talking about network, some service can crash and start at any time, and Studio deals with this for you. And now I can just create these services. Here I'm calling the bar service under the dummy class. And in case of success, I will print the result, and in case of error, I will show you the error. This is the bar service. We just takes the parameter and concatenate with bar. And here, I tell Studio to create this service for this class. So running this application, you can see printing bar, the success bar every second, because they are all running the same process. Now I will show you how can I divide this process in two different processes, and they can find each other and they can communicate without any configuration. So to do this, I created this index foo, which is basically the same JS file, but without the bar service and 2 extra lines of code. The first one is requiring Studio Cluster, and the second one, I tell Studio to use Studio Cluster. And if I run index foo, you will see an error. Studio tells us that he can't find this route, dummy bar. So I also created the index bar, which just implements the bar service and do the same with Studio Cluster. I just added this RPC port because as I'm running 2 processes in the same machine, I need 2 different ports. But if you're running with your friend, you don't need this parameter. And now I can run index bar, and you will see that it starts to find. And I can do more things like stop, and stop, or restart it, and it can find again. I can even turn off my Wi-Fi, and it starts to buffer the message, and it will send the messages when I turn on the Wi-Fi. In the moment that Wi-Fi stopped to work. Actually, the Wi-Fi stopped to work. Now you can see that it buffered. And then I can stop and start it again, and you see everything happening. So this happened without any configuration. You can do this with a machine here and other in Japan, and it will work the same. As I said before, you can use Studio on older versions of Node as 0.12 or 11. And I built this GIS for you with a features map from ES6 to ES5 to use on Studio without any flag on Node. The next steps for the framework are services versioning. Probably most of you already had to change your services and change their signatures, and this becomes a mess when you have a lot of services. So I want to deal with this automatically. I want also to improve the docs. We have good docs, but I think we can improve it a lot. And creating more plugins and spread the word. This is the first time that I'm talking about Studio in a conference, so I'm starting to spread the word, and I want you to test it too. Here you can see the GitHub for Studio and Studio Cluster. You can download this and try in your machine. And thank you.
Thank you so much.
One more thing, I want to invite you to really clone the Git repository and test with your friends, each one running one of the processes, and you see it works without any configuration.